Okay, so yesterday you started the breeding bunnies gene frequency data table. And this is some sample data that you may have gotten for generation 1. In generation 1, everybody started the same. You had 25 dominant alleles and you had 25 recessive alleles. And the dominant trait in this case is fur, and the recessive trait in this case is no fur. So here's some sample data that we could have gotten from table 1. So when you spun the wheel, you had 16 bunnies, or you had 8 rabbits that had fur. And then you spun some more, and then you had 9 that were heterozygous, which means they have the dominant trait and the recessive trait. And then you ended up with 18 hairless bunnies. Now, like I said yesterday, this is in England, and England has very cold winters. So if you're a rabbit with no fur, you're not going to survive. So these 8 rabbits died. And what that means, they died before they reproduced. So all those genes, those 16 recessive alleles for hairlessness, died with them and won't go on to the next generation. So we have to look at what survived and went to being able to reproduce. So if I have 8 of the dominant traits, then that gives me 16 of the dominant alleles. So I have 16 of the dominant traits from here. Then in the heterozygous, I have 9. So 9 of those have the dominant trait. So if I add those together, I had 25 dominant traits. Now the 16 recessive traits here died. They're not being passed on. But I have 9 recessive traits from these rabbits that are. So then I would need to put in 9 of the recessive traits. And so that is what I did. So when I went to my wheel and names to set it up for generation 2, I used those numbers. So I put in the number of the 25 capital letters, dominant trait Fs, and then the 9 recessive traits. And then you do the same procedure that you did for generation 1. Okay, so the first spin gives me a recessive trait. I'm going to remove it and spin again. And that gives me a capital F and remove. So let me go back to my data table. Okay, so I had in my second generation, my first bunny born was heterozygous, had the dominant and recessive trait. So when you do the future generations, you base it on your data from the generation before about what will be passed down. Okay, then today we're going down to, so this should have all been filled out last night. Let's see here. There we go. And so today we're going to look and analyze that data. So on data table 2, notice it says, here you have your generation number on this side. Number of F alleles. And now we're talking about the single alleles, not the genotype. Genotype is 2 of them. The allele you get from your mother and the allele you get from your father. Okay, so let me look back at data table 1. So number of dominant Fs, And if I look up here, I had 16 and I had 9. So that was 25. So then I'm going to come down to my data table. Let's move this out of the way. So 16 plus 9 gives me 25. So I'm going to write 25 right there. And then if I look back up at the top for generation 1, I had 9 of the recessive traits. So I'm going to put 9 right here. Okay. Now, total alleles, just like in math, when it asks you for the total, all I do is add them together. So 25 plus 9 gives me 34. So I had a total of 34 alleles, okay, that were actually passed down. So gene frequency, that's the new thing we're learning today, is calculating frequency. And frequency is just the percentage, and it lets us compare different numbers equally. So we're going to figure out the percentage of the dominant allele for the whole population for generation 1 and the percentage of the recessive. And how you do frequency is the part over the whole, just like you calculate percentage when you're in math. So let's do these together. Okay, so gene frequency for F is column A. Column A is 25. That's the part of the population with that trait, or the part and the number of alleles. Then I put it over column C, which is my total population. And my total population in generation 1 was 34. Okay? And that's my whole population. All right. And so let me get the calculator. Okay. Plug in our numbers. So we have 25. And it's not, oh, because I have one. So we have 25, and it's divided by 34. Now, it gives us this big long decimal. Now, percents, cent means 100. Think there's 100 pennies in a dollar, 100 cents. So we're actually only really concerned with the first 2 or 3 numbers after the decimal. So it gives me 0.73, oops, erase that, 0.735. Okay? Now, I need percent, so I'm going to change that decimal into a percentage by multiplying by 100. And what that means is I'm moving it 2 places. And that gives me 73, oops, doesn't do decimals very well, 0.5%. I could also write 74% if I rounded it. So now I go back to my data table. That's not what I wanted to do. And I write in 74%. Okay? Now you can do your other column a couple ways. You can use simple math. If both of these add up to 100%, I can do 100 minus 74, and I would get my answer. Or I could calculate it by 9 divided by 34. And that's what you do for your whole table. So remember, frequency is the part divided by the whole. If you get a number that's bigger than 1, you've messed up and you flipped your numbers. You want the smaller number up top and the bigger number on the bottom. And so when you divide it, you will get a decimal less than 1. And that's kind of how you can mentally check yourself if you're on the right track. Okay, happy calculating.